Okay, I want to go through some tips and tricks that will help you in balancing chemical reactions in general and also some of the trickier ones. And basically we're always aiming to get the same number of each kind of atom on the left as on the right, as in other words in the reactants as in the products. And I've got 4 ideas for you that you can use. The first is to leave any diatomic molecules until the end, and by that I mean, by diatomic I mean things with 2 atoms, things like oxygen O2, hydrogen H2 and so on. And firstly you get the word equation, and then you write the correct formulas equation, and presumably you've got that, but it's just not balanced. So the first thing to do is set up an inventory of the reactants on the left and the products on the right, and the various atoms that are involved that you have, and work through them, leaving the oxygen in this case till last. So carbons on the left we have 1, on the right we have 1, so that's actually balanced for now. Hydrogens we have 4 on the left and only 2 on the right, so we need to multiply by adding the coefficient of 2 in front of the water, and that will now give us 4 hydrogens. And that leaves us with the oxygens. On the left we have 2, on the right now the coefficient in front of the water actually gives us 2 oxygens, and in fact that's balanced. So this is one of the more straightforward ones, but showing the principles. The second idea is if we've got polyatomic ions, we count them as single units, and in this case we've got some polyatomic many atom ions in the nitrate, and this works if the ion is present both in the reactants and also still in the products, and nitrates on both sides of the reaction, so we can do this approach here. Similarly we have hydroxide on the left and also on the right, so we can also add that to our inventory as just a single entity. Let's count the coppers. So we've got 1 copper on the reactant and 1 on the product. Nitrates we have 2, and but only 1 as a product. So we stop. Immediately we find something that doesn't balance, we stop and fix it. So what are we going to do? We're going to put a 2 in front of the sodium nitrate, and now we've got 2 nitrates. Now what's that affected? Let's just always go and update the inventory for anything else that's affected. And we haven't got to the sodium yet, so we've got 2. That's part of now our new line. On the left we've only got 1. We need to fix that one. So we're going to put a 2 in front of the sodium hydroxide to give us 2 sodiums. Now that's also impacted on the hydroxide ion, which we were going to do next anyway. So we've got 2 hydroxides and 2 hydroxides on the right. So that's actually a balanced equation now. Alright, the third tip, and this might be a harder one, is our hardest one of the 4. If we have to multiply both sides to get a balance, we aim for the lowest common multiple, and hopefully that will make sense as we go through this one. So this is an incomplete combustion of oxygen gas giving rise to carbon monoxide, and again we'll count up the atoms. 4 carbons before, 1 carbon and 1 carbon after. 4 hydrogens is what I meant to say in the reactants, and only 2 in the product, so we're going to multiply this by 2 to get 4 hydrogens, and now the oxygens, we've got 2, and we've got 1 in the carbon monoxide and 2 now in the water. That gives us 3. Now neither of these numbers is a factor of the other, so we're going to have to multiply both sides and aim to get the lowest common multiple of 2 and 3, which is 6. So that's what we're aiming for, and it's easy on the left. We can just multiply this by 3. What about on the right? Well, we've got a couple of options, but I want to even up the numbers. At the moment we've got an odd number of oxygens, so let's put a 2 in front of the carbon monoxide, and now we have 2 here. We've still only got 2 here, so we're going to have to change something. I'm going to multiply this by 4 to give us our desired 2 plus 4, 6. Now hang on, what's this affected? We've done it. Have to update the carbons because that's changed. We've now got 2 in the cross that out. 2 in the products, so we're going to have to change this one. You get 2 in the reactants. That's affected the hydrogens. So we've now got 8 in the products, in the reactants, and happily, by increasing this to 4, we've also got 8 in the product. So in fact, this is now balanced. And finally, the last example is if if you want to, there's actually nothing wrong with using fractions, decimals, halves in the process of balancing, but you need to finish with whole numbers. So balance with halves, then double. And what I mean by that is here's the complete combustion. This often happens in combustion reactions of ethane, now producing carbon dioxide and water. And again, we've got the same atoms involved, carbon, hydrogen, oxygen. And let's count them. So we've got 2 carbons on the left. We've only got 1 on the right, so let's fix that. Hydrogens, we've got 6 on the left. We've only got 2 on the right, so let's fix that. And we're going to multiply that by 3. And now we've got, let's update that. So 2 there and 6 there. And lastly, the oxygens, 2 on the left. And now we've got our coefficients now also have affected oxygen. So we've got 4 plus 3 is 7. How are we going to get, we'd like to increase 2 to 7 to make it balanced, because we've left the oxygen to the end and that's the only thing we need to fiddle with. We can multiply by 3.5. 3.5 times 2 is 7. Looks ugly, and it is ugly, but we're going to just double everything, and that should give us some nice whole numbers. So what was here was 1, doubling 1 to become 2, 3.5 doubled becomes 7, 2 doubled becomes 4, 3 doubled now becomes 6. And we can just check whether we've got everything balanced. We'll go through again and do all our counts. Carbons on the left 4, rights 4. Now we've got hydrogens on the left. 2 times 6 is 4. On the right we've got 6 times 2, 12, sorry. On the right we've got 6 times 2 is 12. Oxygen, 7 times 2 is 14. And on the right, 4 2s are 8, plus another 6 is 14, and we're there. Okay, so there are all the tricks. I'll just summarise them briefly. If you're balancing chemical equations, you begin with a word equation, reactants left, products on the right. You convert that to a formula equation, which is initially unbalanced until you've checked it through. Correct formula is very important, otherwise nothing will work, so you need to know how to write formulas as well. The first thing is to set up an inventory of atoms with columns for reactants and products, and I would advise using a pencil and a razor because you will need to change things about as you go. It's just a to and fro kind of process. Okay, once you've started, I was saying leave any single, and I didn't mention it, metal. So metal is an atom all by itself, usually not want to do anything else, easy to change. Or any diatomic molecules, so as shown here, leave them till the end because you can fiddle with them to make the numbers work and you won't be affecting anything else. If you've got polyatomic atoms on both sides, you can treat them as single units. That makes the calculations, counting much easier. Count one type of atom or polyatomic ion on each side, and this is just the process that you go through. If it's equal in your inventory, well, that's good. Move on to the next one. If it's unequal, stop and fix it by adding a coefficient, but don't ever touch the subscript numbers. And make sure you go back and update the inventory as you go for anything else that's affected by that change. Next, if you need to multiply each side by a different number, aim to get the lowest common multiple of atoms on each side. Okay. Next, aim to minimise changes to other atoms as you go. So if you're picking something to change, make sure that it has the least impact on other atoms. If you need to add half oxygen atoms, for example, in a combustion reaction to balance, you can do that, but you need to end up with whole numbers at the end, so you'll have to then double everything. And lastly, at the end, check that you have the lowest whole numbers possible. Okay, otherwise simplify and basically cancel everything down to get the simplest whole number ratios. Alright, that's the end of my tips and tricks. Hopefully they're useful, and see if you can apply them. Good luck.